Hey, all, we're going to talk about proving today that triangles are congruent. So in geometry, if we want to say that something's true, then we must do something which is called proving it to be true. And when we're talking about two triangles being congruent, if we want to show or prove that they are congruent, then we have four special ways. And those ways are going to include showing that three pairs of the corresponding parts, like we talked about in the last lesson. If we have three pairs of corresponding parts congruent in some way, then we can show the triangle's congruent. And there's four combinations that we're going to talk about that show the triangle's congruent. The first combination would be having all of the corresponding sides congruent. So let me mark the corresponding sides. So if I were given triangle ABC and triangle DEF, and I had all of these markings, so I have AB congruent to DE, BC congruent to EF, and AC congruent to DF, I have three pairs of corresponding sides congruent, then I could say that these two triangles are congruent by the side-side-side theorem. So I have my same two triangles again. This time I'm going to show different corresponding parts congruent. I'll have AB congruent to DE, BC congruent to EF, and instead of having the third side this time, I'm going to have angle B congruent to angle E. So I have two pairs of sides that correspond and are congruent, and I also have a pair of angles that are congruent. And these angles are in a special position. They are the included angles, so I've written included up here. They're in between, or they're formed by, the two sides that we are saying are congruent to each other. So BC makes this angle B, EF makes this angle E, AB also makes angle B, and DE makes angle E. So you can see, even if we go around here, this is one side, angle, side, side, angle, side. So our side angle side theorem has two congruent corresponding sides and a pair of corresponding angles that are congruent and also included between the corresponding congruent sides. So if we have that situation, we have these two triangles congruent by the side angle side theorem. And that means that everything else that corresponds is now congruent. So we can make those assumptions. A is congruent to D, AC is congruent to DF, and so on. Again, with the same triangles, I'm going to mark something different now. I'm going to mark two pairs of corresponding angles. And I'm going to mark a pair of corresponding sides. So if I have two pairs of corresponding angles, and I have one pair of corresponding sides in two triangles, and I know that those things are congruent to each other, then I have triangle ABC congruent to triangle DEF by the angle side theorem. So again, I can label what I have corresponding and congruent, and I almost end up with angle side, angle side. So after we show that they're congruent by angle side, we can assume now or know that angle C is congruent to angle F, AC is congruent to DF, so on and so forth. All the corresponding parts are congruent because we now know that these two triangles are congruent. We also have an side angle theorem. It's a special case of the one we just discussed, angle side. So let me mark up two angles, A and D, B and E. And this time, to make it angle side angle. My side has to be included between the two angles. So this is different than angle, angle, side because the side is between. It actually makes both of the angles that we're using. So again, if I have this case where I have two pairs of corresponding angles congruent, and I have the included sides congruent, then I know these two triangles are congruent by angle, side, angle. We can go through and show. I think if you do that labeling, it's pretty easy to see which theorem we have. So now I know that all the corresponding parts in these two triangles are congruent to each other because I know they're congruent because I have angle, side, angle. So to recap, there are four ways to show triangles congruent. Side, 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 angle, side, angle, side, and then the special case of angle, angle, side, which is angle, side, angle. So it's very tempting to show triangles congruent using these two combinations of corresponding parts, but it is never okay to use angle, angle, angle. That is not a theorem. Angle, angle, angle will not ever show two triangles are congruent. Also, angle, angle, side is not a way to show that two triangles are congruent. Having one pair of corresponding angles and two pairs of corresponding sides be congruent does not prove that the triangles are congruent. And you can see here that maybe this makes a bad word. This is angle, side, side. If you make a bad word on your paper when you're saying that two triangles are congruent, you should know that you are wrong. This is not okay. So pause the video here for a second and see if you can determine which if the two triangles, so these two, see if they're congruent, and if so, by which theorem. And then check these two out, see if they're congruent, and if so, by which theorem. So I'm going to go around and in sort of a clockwise fashion, I'm going to label what I have. I have an angle, I have a side, and I have a side. Here I have an angle, a side, and a side. So I have two pairs of corresponding angles, two pairs of corresponding sides, congruent, and it looks like when I go around ASS, I'm getting a combination that is not making an appropriate word here. So these two triangles, we cannot say they're congruent. So we can't do it. They might be congruent, but we don't have any proof right now. Over here, I'll do the same thing. I have an angle, a side, an angle, a side, an angle. So I have angle, side, angle, angle, side, angle, two pairs of angles that are congruent, a pair of corresponding sides that are included. So this is a yes, they are congruent by the angle, side, angle theorem. And I'm cool if you write ASA. To do the same thing here, try these two examples. Determine if the two triangles are congruent to each other. So again, these two guys and these two guys. And if they are, tell me by which theorem. And if they're not, you should write a little explanation to yourself of why you think they are not congruent.